Okay, Zoom session. Git. We're learning Git, and it's gonna be great. Um, so yeah, I don't have like a super solid plan, but we're gonna roll with it, and it's gonna be good. Um, so I'll share my screen, and I'll s- I think I'll go over these slides. Um, and if anyone has any questions, feel free to ask as I go through this. And I'll try to make some time at the end for if anyone needs me to like debug with them or they're having issues getting set up, getting the homework figured out. I'm happy to help with that. Um, okay, can everyone see my screen? Cool. Okay, so so Git and GitHub, that's the topic we're learning today. Um, so Git is a version control system. There are other version control systems, but Git is the most widely used. Version control software keeps track of modifications to the code. It is critical in enabling development teams to work easily in the same code base, and Git is installed locally on your machine. Um, so if you've ever made something on the computer, uh, if you've done graphic design stuff, or if you've made like written essays or made music. These are all things that I've done on my computer. And a lot of times you have a version of your thing that you're creating and you want to save another version of it. You're like, oh, I want to save my place right here. I'm going to make a bunch of changes, but I want to be able to go back to that saved version. So you say, like, for music, I would make a song and then I'd title it, uh, my song mastered final. And then that's like the final version of the song. It should be going out. And then I notice there's a problem with it. And so I go back and I make final, actually final this time, version two. And then, you just keep on making these different saves of your same file, and it's fully making a different copy. Um, when you're coding, um, you want to be able to save. This is like a big problem that happens in code. And so the way to solve it is version control systems, where you save your place, you save the current state of your code, and then you can make changes and you can always go back to that previous version. You can make different branches of it. And so, if you want to make a new feature, say you're like on the Facebook team and you're like, guys, we need to make Facebook dark mode. And then you start working on the dark mode feature. Um, you don't want to work on the same branch as everyone else. You make a different branch and then make your new feature. You'd call that like a feature branch, Facebook dark mode. And that is like a version of Facebook that is different from everyone else's. It's the deviation is you're adding this new feature, and Git is the thing that can keep track of those changes. And when you're working on a large code base with lots of people, um, so yeah, there's kind of like two main things that Git is good at, which is um, allowing you to save your state in your code and like kind of make checkpoints. Um, and then collaborating with other people. So those are collaborating with other people is like um, you have a version of the project on your computer, someone else has a version of the project on their computer, and you don't want to be um, making like if you make changes to the code and then they make changes to the code, there's going to be like a deviation in your version versus someone else's version of the code, and it would be a pain to have to try to reconcile those differences manually. And so Git allows you to track the changes that you've made in your code and the changes that someone else makes in their code, and then you do something called a merge, which uh, Git allows you to do, and it allows you to, see all the differences. And, you could see, oh, I worked on this feature, I added this feature, and actually some of the code that I added might conflict with some of the code that someone else added. And so you need to resolve that. And that would be, I'm getting ahead of myself. I'm getting deep in, but I have these slides. So I should calm down and follow the slides. So that's what Git is it's a version control system. So it allows you to save your place. It allows you to share your code. It allows you to make different versions of your code, like branches. Um, and if you have ever had like an iPhone and you notice, you go to the App Store and your apps need to update all the time. Um, a lot of apps update like daily or weekly. Um, and those different versions you see, those are actually through Git. Git allows you to do that. And um, it's basically all code. The modern way of making code is you store versions of it, and it keeps track of your progress. It helps you add new features. It helps you collaborate, share your code. Um, and you might have different versions of it, like for production and for development. Um, so yeah, versioning. So that's Git. That is Git, which is a software that's on your computer, and I think it comes installed on most computers. Um, it doesn't look like what you normally think of as an app. Like you can't go like find there's no like icon that you can click on and open Git. It's an application that is it's a terminal application. So it's only in your terminal or command line, which is that thing that makes you look like you're in the Matrix. Um, but Git is a software that it doesn't have an interface. It doesn't have a user interface. It's just uh, doing stuff to your files, and you run commands in your terminal to make it work. Um, there are user interfaces for it, and you can install them and you can use them. And GitHub is actually one that's like an internet. It's online. Um, so yeah, that's Git. GitHub is a cloud-based service that hosts Git repositories. GitHub is not the only option for hosting Git repositories, but it's widely used. So yeah, Git is the thing on your computer that helps you store versions of your code. GitHub is kind of like uh, it's a it's in the internet. It's a website that you can go to. I'll actually show you. I have it open. This is GitHub. You can have a profile. So this is my profile, and you can store different projects. And those projects are called repositories. So these are all different coding projects that I've made. Um, and you could, like, I can check out this React to-dos, and it will tell me basically all the same stuff that Git on your computer will tell you, except this is a version of my code that's stored in the cloud. It's stored like remote is what you call it. So local is your computer, remote is some computer that's a server. Um, and so all this stuff is stored remotely so anyone can see it. If I were to like drop this URL, any of you could see this version of my code that I have stored on GitHub. So GitHub, it kind of enables all the like social parts of Git, where you get to work on a project with other people, all that. And there's actually like, I'll show you, you've probably heard of React. If you haven't, React is one of the things that we teach here at Code the Dream. It's a library for JavaScript for building front ends. And React is an open source project, and it was created by Facebook. So Facebook actually has their own GitHub account, and they have so the entire React code base is stored on GitHub for anyone to see and anyone to work on. And so, React has had, this many 1,652 different people contributing to it. It shows you the languages it was used or that people used to build it. And people can the only way that we can have code that this many different people have worked on is through something like Git. Git enables us to take something coding that is, complicated enough on its own, and allows you to share code between a bunch of different people and have tons of different people working on one code base without having uh, a nightmare of different versions of it going everywhere. It helps us manage all that. And so important to note, it's important to like note just today that GitHub will store one version of your code, one like uh, what's called a repository. Uh, so you have a copy of your code on GitHub, and then you have a copy on your computer. Git is what you use to track or to keep track of all the versions and all that. Git runs on your computer. GitHub is the service that's this website. And GitHub does use Git to do a lot of its stuff. It basically is like showing you a lot of the internals of what Git is really doing. But it's storing a version of your code that is available in the cloud. It's your remote version of your code. So that's the difference between Git and GitHub, and they work together. So you can have a project that's only in Git, and that means it's not stored anywhere for anyone else to see. But as soon as you want other people to see your code, you generally put it on GitHub. And you want to keep your code on, there's this whole kind of like process of keeping your code on your computer in sync with your code on GitHub. Okay, and we have a question from Elena. What about GitLab? GitLab is another product just like GitHub. And it's just an alternative to GitHub. I use GitHub. Most people use GitHub. But I'm pretty sure I think GitHub is more popular for like new developers. I mean, it's popular for everyone, but I think GitLab isn't quite as friendly towards new developers. It's a little more like company oriented. Uh, that's the way I understand it, but they do the same thing. They're competing companies doing the same thing. Um, and they both use Git. And GitHub was actually acquired by Microsoft some years ago. So it was started, I think, as an open source thing, and then, or I don't know. I don't know how it all worked, but Microsoft owns GitHub, just like most other things. Um, okay, so that's Git and GitHub. Using Git, you can use Git through a command line interface or through a Git client. Also, just to zoom out, the reason we're learning Git right now is because we're transitioning away from Code Sandbox. We're going to start writing code on your own computer. And in order to do that, you're going to use Git and GitHub, and you're also going to use a code editor called VS Code. And so, yeah, lots of new tools, but that's how it goes. I'll try to help you get it like a good intro to them. So yeah, we're learning Git because we're going to start writing code on your own computer, and Git is like pretty essential for the workflow of writing your own code on your computer. You can use Git through a command line interface or through a Git client. And then there's and these slides, these are in the Jupyter announcements channel on Slack. Tom posted them, and I think a few other people have posted them too. So they're around, they're floating around. You can find them and click on these links. I would always recommend getting a cheat sheet. Cheat sheets are great for everything. There's cheat sheets for JavaScript, cheat sheets for HTML, CSS, Linux, all sorts of things. Okay, some terms. There's a lot of terms you're going to have to learn with Git. And I think we just go over key important ones here. Um, so a repository, which usually people just call it a repo. Um, it's you can think of it as like a folder or a project. So far your code is stored in Code Sandbox. But even in Code Sandbox, it's in the uh, it's on the cloud, but it's still stored within a folder. And so your code is always stored in folders. That's how computers work, is we have folders and we have files. And a repository is a folder that's being tracked by Git. So you basically tell Git, this software, you say, hey, I have this project with all these, folders and files. It's my code. Um, I want to track this with Git so that I can manage the versions and I can store it in GitHub and do all the stuff that Git does. And by default, Git is not looking over all of your files and folders on your computer. You basically have to initialize a new Git repository, which it's not creating any new folders or files really. It's just telling Git, watch over this folder and keep track of it. Make this folder available to use Git. Uh, and it actually, behind the scenes, it is actually making files and folders. That's how Git works, is it makes a bunch of files and folders that you generally don't see. You don't look at, they're like internal. So you generally don't go poking around in those folders, but in reality, it is making files and folders for you. But you can think of it as just when you want it to track a folder, you initialize it, you tell Git to track it, and then that becomes a Git repository. So Git repository is like a project that is being tracked by Git, and it's just a folder. Um, I'll just read this anyways. In many ways, you can think of a Git repository as a directory that stores all the files. Also, directory means folder. Programmers they have their own names for these things. I think directory existed before folders were even called folders, but just know when you see directory, that means folder. It's the same thing. It's just what coding people usually call a folder, is a directory. So repository, repo, directory, folder, all basically the same thing, except a repository is specifically a folder that's being tracked by Git. So in many ways, you can think of a Git repository as a directory that stores all the files, folders, and content needed for your project. What it actually is the object that, yeah. Okay. Don't worry about that. That's getting too into the weeds about it. Repositories are not limited by user and can be shared and copied. See fork. Okay. They can be local or remote. Oh yeah. So local would be on your computer. Remote is on GitHub. Okay, branch. So I mentioned this briefly, but a branch is a version of your code that is like specifically set to be it. I think it's pretty intuitive by the word. Um, it diverges from the main working project. So normally your versions will be like linear. So you make a change and then you make another change and then the next change and then the next change. But if you want to go back to a previous change, you can branch off of that previous one, and then you can have diverting branches that, if you had like a version of your code from a year ago and you're like, actually, I want to go back to that version and make a branch. You could do that if you want. So there's this whole like timeline thing to think about, and your history in Git. And so a branch means one point in your code can have multiple future versions. And so that is what a branch is. And it basically means when you're making checkpoints, they're not going to be all on one timeline. You can have multiple different timelines. And so they're on different branches. That is useful for working with other people. That's kind of the main use for branches, is you can have your own branch and someone else can have their own branch, and they're not going to be conflicting with each other. You can make your own changes, they can make their own changes, and they're on different branches, so they're not going to be conflicting. And you can also have a branch that is automatically being deployed. So your main branch, every Git repository has one main branch, and that one, a lot of times people set it up to be automatically deployed. So if you have a website, your main branch a lot of times is what's actually the like real version of your website. So the code that makes up your website is actually the main branch. And then all your other branches are like you testing out new things. Um, and you can have branches that are local and you can have branches that are remote. So yeah. A version of the repository that diverges from the main working project. Branches can also be new versions of the repository, experimental changes, or personal forks of a repository for users to alter and test changes. Okay. And just so you know, some of these are commands that you're going to run, and some of these are just terms. So there is a branch command. There is a checkout command. There's no repository command. To make a repository, you run git init to initialize a repository. But I'll go through these commands. Okay, git checkout. So this is a command that you need to know. The git checkout command is used to switch between branches in the repository. Git checkout testing L would take you to the testing L branch, whereas git checkout would drop you back into main. Be careful with your staged files and commits when switching between branches. Okay, so basically what that's saying is if you have two different branches, you can switch between them using git checkout. It's kind of like, well, it's not really like you're at the grocery store checking out, but kind of. Checking out different branches. This is the command you use. And you can also check out a previous version of your code. So, a big part of Git, like I said, is keeping different versions. So you can see the full timeline, the full history of the changes you've made, and you can check out any previous point in your code with git checkout. So for checking out different branches or checking out previous versions of your code, that's what that does. Clone takes a copy of your repository. A clone is a copy of your repository or the action of copying a repository. When cloning a repository into another branch, the new branch becomes a remote tracking branch that can talk upstream to its origin branch via pushes, pulls, and fetches. Okay, lots of terms here. The basic idea of clone is a clone is you have a version of your code that's on GitHub, and you want to pull that version onto your computer. So like if I wanted to work on Facebook or React from Facebook, I could pull their code base onto my computer. And not only am I getting their code, but I'm getting the history of their code too. I'm getting all the information that is stored in Git, which is all the history and all the different branches and all that. And you can clone a repository to your computer, which means it's almost like as if you were to take the project, the like folder and files that make up the project. It's almost like if you were to take that and just pull it onto your computer, like, drag and drop it. But a clone is special because it doesn't just give you the code. You don't just take the code, but it actually has Git. It's like the code with Git. So Git is automatically going to be aware of the history, and it's going to link your version of that code on your computer with the remote version. So if you were to make changes, to React and you wanted to send those off to potentially be incorporated with the real version of React, you could clone it to your computer, make those changes, or you'd clone it, you'd make a branch, you'd make those changes on your branch, and then you'd push those changes to the React on GitHub, and then someone would look over it and say, I like these changes. I'm going to incorporate it. And you can pull it into the main branch, or someone else would do that after like a code review. And so just really quick, I can show you, this is actually branches here. So we're looking at the main branch on GitHub. There's 356 different branches, and you can actually scroll and look through different branches. So these would be different versions of the code that other people have created, and then eventually the branches typically end in getting merged with the main code base. So clone is taking a version of some code on GitHub and taking it and putting it onto your computer. Fork, we're not going to be using fork just yet, but fork is similar to clone. It makes a copy, but it actually makes a copy on GitHub, on your profile. So instead of having a version of the code that is actually linked to the actual like React from Facebook, you could clone it so that you make a version on GitHub that's your own version, and then you can clone it after that. So a fork is making a clone that's actually on GitHub under your profile. That's the difference between a fork and a clone. Is fork is I want to create a new version of this code that's on my GitHub profile. And then clone is I want to take this code that's on GitHub and pull it onto my computer and have Git sync up those two versions of code, the local and remote. A merge is taking the changes from one branch and adding them into another, traditionally main. These commits are usually first requested via pull request before being merged by a project maintainer. So merge is what it sounds like. It's taking a branch and integrating the code of that branch with another branch. And so the typical version is you make a feature, and then you make your feature on a different branch, and then you want to incorporate that feature with the main version of your code that is like deployed to the world. Say you add a new button to your homepage of your website. You add that new button, or like you make a new branch, you make the button, you change your code to make a button, and then you want to incorporate that with the actual version of your website that is available on the internet for everyone to see. You would want to do a merge. And so you'd merge your branch, which takes the changes that you made and incorporates them with the main branch. So that now the main branch, and therefore your deployed version of code, is updated with your new button or your new feature. So that's a merge, is taking the changes from one branch and integrating them with another branch. A pull or a pull request. These are actually two different things. So I'll talk about a pull first. Pulling is taking so if someone makes changes to a branch on GitHub and you want those changes on your computer, because your version of Git on your computer can get out of sync. It can like be outdated compared to what is out there online. Like if I pulled the React code base, the React repository onto my computer, or if I cloned it onto my computer, Git isn't going to track if that version on GitHub changes. If people are making changes, my version on my computer isn't going to automatically update with those changes. And so if there's branches being updated on the remote version and I don't have those updates yet, you can pull to take those branches and merge those changes onto your own branches. And that is actually what it's doing, is it's doing a merge. A pull is a merge that's merging from like the remote. Um, and a pull request is asking, it's pull requests are only on GitHub. They're not a thing on normal Git. So Git on your own computer does not have the concept of pull requests. Pull requests are only a GitHub thing. So they're only in the like website, GitHub, pull requests. And you can actually see there's a tab right here, pull requests. So I could click on pull requests. These are pull requests. And what they are is, and you can actually see there's a little icon right there that I'll screenshot that. Can I make it bigger? There we go. Okay. That is, that icon is showing there's a branch, and then there's another branch with an arrow. So this branch is getting merged into that branch. So that is what a pull request is actually doing, is it's saying it's a request to merge. So you have like your own branch, your own feature, you make some changes, and then you go, I want to incorporate these changes with the main branch, but instead of just doing it, instead of just going, okay, I'm merging with the main branch, you actually set up a pull request, which is like, it's kind of like a staging for a merge. It's like before you merge, you get to see what's actually going to be changed, what's going to change from the code when you do this merge. And what that allows is for other people to look over the code that you changed and review it before they integrate it with the main branch or with any other branch. So generally, a pull request is you saying, I made this change. Can someone look over it and decide whether to merge it with the main branch? Because once you merge it into the main branch, it's out there. You know, that means the main branch is now the version that like typically is out there for the world, and you don't want to merge something into the main branch willy-nilly. You want, you know, if you're on a team of people, you want people to look it over, do a code review, and have a discussion about it. And so usually a pull request, if I were to click on one, someone describes what they did. This lets us blah, 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 do this stuff. And then there's going to be a discussion usually. People like comment on the certain changes that they made. Someone else might look at it and go, I don't agree with that change. Shouldn't this be, you know, you should have used let instead of const, or, you know, this is an infinite loop. Why are you trying to merge that? So you can have like a discussion that's ongoing for a pull request, which is basically like, until we decide to merge this feature or this change to the code base, we're going to be able to have the option to review it, see what's changed. You can go to files changed. And it shows you like the minus sign is lines removed and the plus sign is lines added. You can see total lines removed and lines added up here. You can have checks that run. So you can have like automated tests that run that ensure, you know, if you have automated tests that run over your code that ensure all your things are working right. A pull request is the time to run those tests, those automated tests, because it's the time where you are about to integrate your changes with the actual real deployed version of your code. And so you want to run those tests and make sure they all pass before you merge with the main code, or else you might break things. So that's what a pull request is it's like a pre-merge on GitHub that you and your team can look over the changes and review each other's code. And so usually in the actual like the world of developers, your kind of final body of work for a day or a week will be a pull request. That's kind of the culmination of your work for a certain thing. You know, say you add a new header or a new, you know, navigation to your website, and that was your work that you did. You would make a pull request, and then that's for your team, your boss, you know, whoever to look over and go, okay, I like the changes that you made. Let's integrate those with the main version of your code. That is a pull request. And pull requests, when you resolve them, it does a merge. So that's the end result of a pull request. Or you can close it. If you don't like what the person changed, then you can close it. I don't have there's like a lot of permissions on, you can set up different permissions. I don't have the ability to merge something on the React code base. So yeah, just so you know, like just because I could pull this React code base, I could clone it onto my computer and make changes, does not mean I can just change React. There's checks and balances. There's all sorts of things in place. And one of the main ones is pull requests. You can't merge your code with their code until it's been reviewed and people have okayed it. But if you are working on your own projects, you can do a pull request and you can merge it on your own. And that's what you're going to be doing in our assignments. So pull and pull requests are different things. A pull is taking a version of like a branch that's on the remote server and pulling it onto your computer, like getting those updates because your local version isn't going to automatically update. Pull requests are, hey, I made some changes, and they're only on this pull request only exists on GitHub. It's I made some changes. Can someone look over the changes I made and potentially merge them into the main branch or whichever branch? You can do a pull request from one branch into any other branch, but typically it's a feature branch into the main branch. Oh, sorry, scrolling. Okay, at this rate, it's going to take me hours to get through, so I'll try to speed up. I tend to be a rambler. Okay, push. So a push is kind of the opposite of a pull. A pull is there's code on the remote branch that you want. So you pull from GitHub onto your computer. A push is the opposite. It's code that you made on your computer and you want to update the version on GitHub. And so you push the updates that you made on your computer to GitHub. So updates a remote branch with the commits made to the current branch. You are literally pushing your changes onto the remote. So anytime you're making changes and you want other people to see those changes, you would do a push. And then if you want to merge it, if you're done with the branch and you're like, this is a completed body of work, then you would do a pull request. So push, pull request. Remote, we went over this, but a remote is just the version of your code that's stored on GitHub or any other service like GitHub, like there's GitLab, and there's other ones. But really you just need to worry about GitHub. That's like the industry standard. So remote just is referring to the version of your code that's not on your computer, it's on GitHub. Yeah. Okay, this is kind of a changing directions here, but an IDE. So we're stepping away from Git for a minute. An IDE, this is the actual program that you're using to write your code, or that you're going to use to write your code. It's VS Code, so Visual Studio Code. This is the most popular IDE right now in the world. It's changed. There's plenty of them out there, different ways to write your code. You could even, if you wanted to, you could write your code in TextEdit. If you've ever opened TextEdit, if you're on a Mac, or Windows has their own version, but you could open like TextEdit. If you wanted, you could write your code here. Or you could write it in Google Docs if you wanted. But there's a lot of conveniences that an IDE offers, or a text editor is another thing that's similar to an IDE. So specific software for writing code. And really all you need to write code is a way to write letters, words, like you could write code in Google Docs, but or a Word document. But an IDE it's It stands for Integrated Development Environment. Um, and it's basically a tool that allows you to write code and also do a bunch of other useful things for programmers. So like Code Sandbox, that's pretty much an IDE. It's an IDE that's uh, in the cloud. It's on the internet, on a website. And so VS Code is going to look really similar to Code Sandbox. They actually use the same like user interface library behind the scenes. They use like a lot of similar things. So it's gonna feel familiar, VS Code and Code Sandbox, and they're both just a program that you write your code in, and it also has ways for you to run commands. So it has a terminal, it has a file browser. So this is what you see on the left here. Um, these are your different files, and it's the same thing as like if you were to go and like Finder on your computer or Explorer on a Windows. Um, you're seeing your files and folders right here. And some of the useful things that an IDE offers are like syntax highlighting. So that's why your code is different colors. Because there's something called syntax highlighting, which allows you to kind of like get visual cues, easily differentiate between functions and variables and keywords, and you'll start to see like, oh, certain things are always certain colors, and that just helps you easily glance at code and uh, make sense of it better. And it offers like suggestions, and yeah. So an IDE is your environment for developing code, for tech or text editing. There's a slight difference between a text editor and an IDE. An IDE is more like uh, bulky, and a text editor is more slim. Um, VS Code is technically a text editor with a bunch of plugins you can download for it. And so you basically make it into an IDE by customizing it and adding all of your own kind of features through plugins and stuff. Um, technically, a text editor is more bare bones, and an IDE, like some IDEs different from VS Code, are like specific for developing in a certain language. Like Xcode is Apple's product for developing in Swift or Objective-C, which are Apple's programming languages. And so Xcode is like very, very specific for Apple, like developing Apple software. And it has like an iPhone simulator you can use and all sorts of crazy stuff that VS Code is pretty bare bones compared to some of the other ones, but it's amazing because it has all these plugins and I really like it. So you'll be using VS Code to write your code. Okay, command line interface, also called a terminal. Um, it's that thing that makes you feel like you're in the Matrix. It's the uh, it's the place where you run commands which make your computer do things. So, the earliest computers didn't have like a mouse. Like the very earliest computers ever made did not have a mouse. Um, they basically just had a keyboard, and they have like a text input, and you just type things. You type what you want the computer to do, and it just shows you something that looks like this. It's just text. Eventually, things like graphical user interfaces, GUIs, came about, but the original computers were just text-based. And you could do stuff. You could ask it to, do math calculations or whatever, or, store files and documents and whatever. You could have it do stuff, but it was all text-based. And so developers, we still use terminals, even though computers have moved past that. We have graphical user interfaces, but the reason we use terminals is because you can make applications like Git that only run through the terminal. Like you can't trigger it through like clicking on buttons and stuff. You trigger the application to run through commands in your terminal. And it turns out it's nice for developers to be able to just make things and not have to worry about making a graphical interface for them. Um, And it also makes it easier for like servers. You can uh, like put your website on a server, put your application on a server, and servers don't even need to be able to render like a graphical interface. So servers can be really bare bones. Their operating systems can just be like, super um, minimal. And to be able to like work a server, you just use a terminal. And uh, there's lots of reasons why terminals are nice. One of them is you don't have to tell people like click this button and then click this button and then move your mouse over to this side of the page and then click that thing. Um, they're much more like uh, declarative and harder to get wrong. So you can just copy some commands that people put and then paste them, and it'll do the same thing on your computer, as opposed to having to give people instructions through like clicking on buttons and stuff. So uh, yeah, developers use terminals a lot, and you might feel like it's slow at first and you don't understand why, but eventually you'll hopefully learn to like them. I like terminals, uh, but they definitely are like not um, they're not very user friendly at first, and ever really. So, but yeah, it's a way of running applications, running commands using Git. So everything we do through Git is going to be through the command line. So you can see we're typing commands, git diff, git status. You can type things in here and you can see the output of things. So um, that's that. Um, yeah, command line and terminal. Command line and terminal is basically the same thing. The terminal is like the program and the command line is the actual like um, ability to run commands. Um, and I should also mention really quick, there's something called Linux. And if you haven't heard of Linux, then uh, Linux is an operating system in the same way that Mac is an operating system. There's Mac OS and there's Windows. So there's Mac, Windows, and most people just think, people who aren't developers, they think Mac and Windows are like the only operating systems for computers. Turns out there's another one, and it's called Linux. And Linux, see it spelled right here, Linux. Linux is actually more popular than Mac or Windows because all servers run Linux and phones, and not all phones, but uh, not all phones. Apple phones don't run Linux, but Android is like a Linux based thing. Mac is actually based on Linux. So Linux is actually kind of like the parent of all operating systems, or not all, but it's the parent of Mac and or they're actually based on Unix, which anyways, I'm going to get into the weeds about it, but just know Linux is um, it's the operating system that allows you to run commands on your computer, basically. You can think of it that way. There's much more nuance to it, but just think of when you think of Linux, think commands in your terminal. Okay. You will only need to do these things once. Okay, so we're getting started with installing Git. Uh, and actually, I'm gonna break out of the slides for now, and I'm just gonna walk through the assignment in like actual uh, like I'll just walk through the Code the Dream assignment. Okay, so we're learning about Git. We're gonna set up Git, and we're also gonna set up VS Code and GitHub, and we're gonna write some code on your computer, not using Code Sandbox, which this is the way that like, professional developers do it, is they write it on their computer using uh, programs that they use to write code. And Git is going to be they're really putting an emphasis on this. Git is just a part of, it's not essential for writing code. You can write code without using Git, um, but it's useful. So most programmers use Git. Um, okay, so we're going to go to the assignment. Okay, so we're going to start by creating a new repository, which if you remember, a repository is a project that is stored or it's tracked with Git. We're actually going to make this one. So you can make your project, you can start your project on your computer, like local, or you can start it on GitHub. Like you can create a new project on your own computer, or you can create one on GitHub. They're having you start by creating one on GitHub, and then we're going to clone it to your own computer. But we're going to start with GitHub. So go to your GitHub page and click the repositories tab. And maybe I'll split this up so we can. Okay, so I have GitHub on the right here, and I have the instructions for Code the Dream assignment on the left. So it says go to your GitHub profile page. If you don't have a GitHub profile, then make one because you gotta. And click the repositories tab. So the repositories tab, I think it depends on where you're at in GitHub, but the way I usually get to it is I click my profile and then your repositories from this sidebar. Okay. Click the green new button. So these are all the projects I have. You probably won't have any, or you might just have one that's, I think you start with one that's called your username on GitHub. So you're just going to click this new button to create a new repository. Now we're on the create new repository page. Fill in the fields to give your repository a name. Use your name/class name as the name example, or as the name example, and then they show you an example. So we're naming our project, and you want to get this right. There's a student I was just helping who got it wrong, and it's kind of a headache when you, I mean, it's not that bad, but you definitely have to repeat some steps if you want to rename your repository and you've already cloned it locally, because then you have to do all that. So we're going to name it right the first time. What you want to name it is use your class name or your name-class name. As an example, Maria, Santiago, Jupiter. So I'm going to name mine Rio Edwards, my first and last name, and with dashes in between, Jupiter. So that's going to be the name of my new project, Rio Edwards Jupiter. And all of our code that we're going to write in this class from now on is going to be in this repository that we're making here. And you can give it a description. So they have an example portfolio project for intro to programming course with Code the Dream. Okay, so I'll just copy that and I'll paste that in for the description. Not totally necessary, but it's nice to describe what this project is. So it's a portfolio project. We're going to be making your portfolio websites. That's kind of, we've learned JavaScript and we're going to start learning HTML, CSS, and then we're going to make a website and it's going to be your portfolio and it's going to be out there for, well, I don't actually think they explicitly show you how to deploy your code, but they might. If they don't, then I'm going to host a session on how to deploy it so that it's out there for the world. But yeah, we're going to make your own portfolio website and it's going to be your own website. So you can have your own website and it's going to be good. So that's what we're making. Be sure public is selected and check the initialize this repository with add a README file checkbox. So this is not actionable here. This is just making sure that this is checked by default, which it is. Oh, wait. Sorry, this should be checked. Check that. Initialize this repository with add README file. And a README file, this is like a programmer's way of, you go to the README if you want to, it's like the entry point for a project if you want to provide like information for other developers. So that's you basically just it's not for code, it's for instructions on you know telling other programmers what is this project and what are any information you need, you go to the README file first. So we're going to have it add one by default when we create this. And then click create repository. Okay, so I'm going down here, create repository. Okay, so now under my username, I have this new repository, Rio Edwards Jupiter. So this is my new coding project. It doesn't have anything in it except for a README file. And the contents of that README file are actually shown right here. The contents are, it's written in a language called Markdown, and it's for rich text. So you can have it display text in different sizes and links and stuff like that. So this is my contents of my README file. And that's it. It's a pretty empty repository. It just has this one file called README. And it's not on my computer. This is only on GitHub. And so the next step is cloning to your local machine. So you want to take this pretty empty project and clone it to my own computer. And the reason we're doing that, even though there isn't much in here, if you make a new project and then you clone it, then Git automatically is set up to track, like sync up those two projects. It doesn't like keep them in sync. You have to run commands to keep them in sync, but it does link them so that it knows, okay, these files on your computer are actually linked to these files on GitHub, so that when you are making changes and you're pushing and pulling from your remote server, Git knows that this is the version of your code that, or this is the repository that you are linking to. So by making it on GitHub and cloning it, Git automatically is going to be set up to track that code. Okay, so now we're taking this project and put it on your computer. So copy the repository you just created in GitHub to your local computer by following these steps. Open the main code page of your repository, click the green code button. They say it's green, it's actually blue now. I think it's sometimes green, but no, it's blue. I don't know. We want to click this button called code. And then your lesson walked you through setting up an SSH key with GitHub. You should select SSH key as the local clone type, not HTTPS. Oh, there is a step that I skipped. There's, I think this lesson is going to be pretty long anyways, so I'm going to skip it. But you should have done this. There's a link right here. Odin project, setting up Git. This is something that you should do. This sets up Git on your computer and stuff. So do that first. I would do it, but this is just going to be a really long lesson anyways. So yeah, I'm going to skip that. So assuming you've done that, click the cop, or your lesson walked you through setting up an SSH key. You should select SSH as the local clone type, not HTTPS. So what they're saying is click code, and then here where it says HTTPS, click SSH instead. And then click this icon that is to copy. So we're going to click that, and then that copies this thing here. SSH, click that. And then go to your IDE terminal or your computer terminal. Make sure that you're in the proper directory for where you want to create and store files for your work. And then run git clone repository, where repository is replaced with the last portion you copied in the last step. Okay, so what they're saying is now we need to open your terminal. And if you've never opened your terminal or your IDE, first of all, you should have installed VS Code. That's another thing you should have done, I think, at this point. I don't think they're going to walk you through that. So install VS Code. And I'm just going to open my terminal. And the way you can do that is you can use this. I like to use search, which there should be. I've modified my menu bar, but there should be a little search thing. You can also just go to your applications folder in Finder, or just wherever in Finder, and search terminal. And find your terminal app, because there's an application by default installed on your computer called Terminal. I think on Windows it might be different. I can't remember. On Mac, it's called Terminal. I have my own version, my own terminal called iTerm, which is the kind of better terminal for Mac. So I'm going to use this one, but it's the same, just looks a little different. So I open my terminal, and this is a command line. So we can imagine I'm just empty command line here. And I'm going to run some commands that are going to take the new project I made on GitHub and pull it onto my computer. So go to your terminal, make sure you're in the proper directory. Once again, I think if you do the assignments here, they walk you through some commands, some terminal commands. I'm not going to explain too in depth the commands you're going to run, but I will just briefly show you them. So what you want to do is go to the folder that you want to clone your code. And so you can make a new folder. You can make it through Finder or Explorer, or you can make it through the command line. It's all the same. I'm going to change directories, and I'm going to go into documents. And I think I have a folder called Code the Dream and Jupyter. Okay, so I'm running ls, which lists files in the current folder. So I change directories, and I put the file path or the folder path that goes into a certain folder, because your terminal is always relative to a certain folder on your computer. And then I changed into the place that I want to clone my code, which is this folder. You can open it if you want. On Mac, you can run open dot. If you run open dot, then that opens Finder in that folder. So it's the same thing. You can see users, Rio Redwoods, documents, CTD, Jupyter. That is the location that it will open your Finder. So that's where I'm at. I'm in this folder right here. And here I'm going to clone my code. So I copied that thing from clicking clone, copy to clipboard, make sure to select SSH. Actually, to be honest, I don't think you need to. I usually do HTTPS, but if you're having troubles with SSH, then use HTTPS or ask someone to help. Okay, so I'm in the correct folder. You can do print working directory, PWD, which tells you which folder you're in. And then I'm going to do git clone, and then I'm going to paste. Oh, wait. Make sure to copy this. Copy that, git clone, paste. And so what that does is it takes that project that's on GitHub, and it pulls it onto your computer with all the Git stuff already set up to track everything. So this should be a new file on my computer, and I can actually, or a new folder, go into my Finder, and I can see it here, Rio-Edwards-Jupyter with a README file. So this folder was not here before, and it's now here because I ran those commands, which took that folder from GitHub and put it on my computer. So that is cloning a folder from GitHub or a project and putting it on your computer. Okay, so now we have that folder. Now let's get organized and write some code. So navigate into the directory you just cloned by running cd. So actually, oh wait, I didn't do that yet. So I can do that. So cd, which is change directory. And I'm going to start typing in the name of my directory, which is Rio, whatever. But little hint, you can just press tab and it'll auto complete. If there's only one option, it'll autocomplete it for you if you press tab. If there's multiple options, it'll list those options out. So use tab to autocomplete in your terminal for going faster, doing things faster. Okay, so we changed into this new folder, and now we can open it, or actually we're going to create a new branch, a new GitHub branch. And so the way to make a new branch is you run checkout-b and then the name of the branch. So git checkout-b and then lesson 5. So git checkout-b, and that creates a new branch. Git checkout itself can allow you to check out any different branch. Git checkout-b says I'm making a new branch. And we're going to call this new branch lesson-5. And then if I run git branch, that actually lists out, git branch, that lists out the different branches. Right now there's main, which is the default, and then lesson 7, which is the new one I just made. Okay, open the README file in your code editor and add your full name. Okay, so we need to now open this in VS Code. So if you have VS Code installed, then you're good. If you haven't installed it yet, then install it. And then I would normally run, there's a command you can run, code dot, if you have it set up with VS Code, there's a way to do it. You can look it up, VS Code add to path, running Visual Studio Code on Mac OS, launching from the command line. So I would follow these instructions in VS Code, which allow you to do this. You can say code dot, and then it'll open the current directory in VS Code. Yes, I trust the authors. So we just pulled some code down from the internet. It was from my GitHub profile, but VS Code is going to ask, do we trust where this code came from? Yes, I do, because I made it. Okay, so now we have VS Code open, and we can see in the file explorer, I have this one file called README. A lot of students trip up this one part. If you open your code editor in the wrong location, this side here will look a little different. So I'm going to show you what it looks like if you open it in the wrong place. So if I change directories back 1, if I were to open my VS Code right here, so I'm pretending to accidentally open it in the parent folder. So I accidentally opened it in the parent folder. What are we seeing? Well, we're seeing the parent folder is maybe called Code the Dream. In my case, it's called Jupyter. And then you can see a folder inside called Rio Edwards Jupyter, which is the actual project we want. We want this name right here, like the very top name right here, to be the name of our project. It should be your name dash whatever. I'm simulating accidentally opening this instance of VS Code, this window of it in the parent folder, which you don't want to do. You want to open it in this folder. And so the way to fix that if you open it in the wrong one is you can just open up a new window in VS Code. So I could say new window, or I could say open folder. I'll do open folder, which will reuse the same window. And I'm going to, in Finder, select the correct folder, which is Jupyter, Rio Edwards Jupyter. And this should just bring up, yeah. So make sure that you open it in the right folder. Okay, what's next? Okay, so we're going to open the README file. So we made a new branch, opened it in the code editor, and add my full name to the README file. So Rio Edwards. Sure. Okay. And then you can save. Remember to save. Command S to save. Um, and then we're going to create a new file and call it index.html. So we're going to make an HTML file in this same thing here. So we can see this Explorer here with one file called readme.md. Yours might look a little different. Your whole code editor might look different. There's like lots of themes you can add and different colors and all sorts of stuff. The icons might be different. Generally, it's all just a different skin over the same thing. So don't worry about it if it looks different. You can click this to add a new file, or you can right click an empty space in here and say new file. And then we're going to call it index.html. The reason it has that icon is it's an icon theme that I have, and you probably will have a default one too that it determines the icon, the file extension. So it's an HTML file, and it'll have the HTML logo there. Okay, so we made a new index.html file onto backing up to the cloud. Make sure your code gets copied to GitHub by adding changes to staging, committing the stage changes, and pushing them from your local machine to GitHub. Okay, this is a lot of, oh, I think they do, yeah, okay, they walk you through this. I was like kind of throwing you in the deep end here, but they walk you through each step of that. Okay, so check the status of your changes you just made, editing the README file, and making a new index.html file by running git status in your terminal. Okay, so we're going to run a command called git status, and that's going to tell us, that's just generally, if you're in a Git repository and you're making changes or whatever, git status will tell you information. So git status. Okay, so we're on a branch that we just made called lesson 5, which is where we're making this, each lesson you do each week is going to be its own branch in GitHub. So we're on lesson 5, so we made a branch called lesson 5. Changes not staged for commit. So we modified the README file, and it's not staged for commit. And actually, I'm pretty sure the slides did not cover commits or staging. Commits are your actual so Git is for version control, right? And you are saving your place, and you have to manually decide, like tell Git, I want to save my place right here. Like the current state of my files and folders, I want to save and have it be like a checkpoint in history that Git tracks. In order to make that like save state in time, you have to do a commit. So a commit is the word, that's the command for saving your place at any point in time. So that is kind of the core like building block of your Git repository. Is it's a series of commits. Commits can be on different branches. They have like, they're different places in time. They're kind of like on a timeline. So commits are kind of like your history of save states. If you make a new branch and you want to like, update changes, you have to do a commit. And then, so commits are like pretty much before you do anything, you do a commit. And I know there's a lot of commands. So the general workflow is once you've done like the setting up of your repository and you've cloned, the general workflow is make a branch. So git checkout -b and then the branch name. And then write your code, make your changes, and then git add. And so I'll do that now. So you can do git status, but you don't have to. That's just for displaying stuff. What you really want to do is git add, and then you can do dot or -a. I do -a, capital A. Git add all. And what that does is it stages these changes to be added to the next commit. So now if we do a commit, it will include the changes that we stage to the commit. And so if you want, you can save, you can do a commit that doesn't include all of the changes. So if you made certain changes and you want to say, I want to save a version of my code, but don't include these things, don't include a specific folder or file or something. That's why there's like a staging before committing. So there's committing is a two-step process. It's add, which stages your commits, and then commit. Or add stages your changes, and then commit commits those changes, which is like a creating a new save state. So we're doing git add -a, which adds all of your changes that you made to the staging area to be committed. And then, yeah, so they say git add dot here. I do git add -a. I think it's better. I don't remember exactly why. You can do git status again. I don't have to. Create a commit message for reference. So git commit -m, my first commit. So that is how you do a commit. So we're doing git add and then git commit. So git commit, and then a commit needs a message. That's how you tell it. That's how you can you can use the commit message to reference where you were at that point or what you did. So you generally write your commit to describe what work you did since your last commit. So you can look at your series of commits and it'll show you the history of changes you've made. For this first commit, we're just going to call it my first commit. It's not describing any changes we made. It's just saying this is my first commit. And then hit enter. So that makes a new save state, a new commit with a message that we can refer to called my first commit. Okay, we're going to push the changes now to GitHub. So GitHub is now out of sync. GitHub doesn't have those updates. On GitHub, it doesn't know that we added my name to the README file, and it also doesn't know we made this index.html file. If we look on GitHub, it does not have those updates. And so a push is how to tell GitHub, hey, update the remote repository with my local repository, with the local changes I made. So we're going to push the changes to GitHub from your computer by running git push origin lesson 5. Git push the changes to origin. And lesson 5 is the name of the branch that we're pushing. Oh, I did _5. Needs to be -5. Okay, and that worked. So git push origin lesson -5. And then I'll do this thing. And when you get an output that looks like this, it does a lot of stuff you don't need to know. But the main important thing is you want to be able to see something that says something about creating a pull request by visiting a URL. So this is telling you we now have a branch on GitHub that matches the branch that we just made here with these local changes. If we wanted to merge these changes, imagine we just added a bunch of code and we made a bunch of new changes and features and stuff. We could do a pull request and tell someone, hey, I want you to merge these changes with main. And so it's prompting you, if you want, you can make a pull request as a suggestion. Okay, and so now on GitHub, we can see we have those updates. And the way you can tell is you have this thing on the main thing that says lesson 5 had recent pushes 2 seconds ago. So I just made changes 2 seconds ago. We now have a version, or we now have a branch on GitHub called lesson 5. And we could do view all branches and it'll actually show us lesson 5 there. And it'll have a button for comparing and pull request. So that is an easy way to create a pull request. And a pull request is actually what we're going to do to submit your assignment. So we're not really writing any real code here in this lesson. We're just kind of getting all this stuff set up. And it's going to take a lot of muscle memory. It's going to take practice going through how Git works, how GitHub works, how the command line works, running commands in the command line, using Git in the command line, using GitHub, creating pull requests, writing code in VS Code. There's lots and lots of new things. And so this week, we're not doing any new code. We're not learning any coding concepts, really. We're just learning setting up your computer and getting a hang of the workflow, which you're going to mess up. You're going to get problems with Git. It's going to give you errors and you're going to end up in weird states where you're like going to need help. And so reach out, because it's pretty much like a rite of passage. Every programmer that is learning programming is going to have problems with Git. It's just like everyone does. Git is great and it's awesome, but it's very confusing to learn. And when you get in a state where things aren't working right, it's really hard sometimes to figure out what went wrong. And you're going to end up on Stack Overflow, and people are going to be talking all sorts of crazy stuff. And so feel free to reach out to me or any other mentors or anything like that if you get stuck in Git stuff. Okay, but we're not stuck. We're doing it. We're going to click this compare and pull request, which is going to remember, if you were working like a real coding job, this would be, you did your work for the day or the week or whatever, and you want to tell your team what you did, and you want that code to be merged into the main branch. So you create a pull request, and then someone else is in charge of looking it over, reviewing it, and in this case, it's your assignment reviewer. We're going to create a pull request, and your assignment reviewer is going to look at your pull request and review it and give you an A+ or whatever. So, okay, so you clicked the green create pull request button. I think it actually misses a step right here. You need, or maybe it doesn't. Compare and pull request, and then click create pull request. So create pull request right here. So it's two buttons. You do compare and pull request, and then you have to confirm the pull request. So here it is. This is my pull request. And this is now the link to this pull request, this URL right here. This is what you're going to submit as your first assignment, or your fifth assignment. This is like how developers kind of keep track of a certain body of work, a certain set of changes that you made since the last thing. So we can see the changes we made. You can go to files changed. We added a new index.html file that's empty, and we added my name to the README file. There's a couple spaces. My formatter added that automatically. Don't worry about it. Sweet, I got a comment. Amazing. What does that stand for? I'm bad at acronyms, so I don't know.
It looks good to me. It's a standard
Oh,
lazy response
okay.
to not giving detailed feedback.
Amazing. Okay, so my PR was, which PR, that's more jargon. PR is pull request. So you get tired of saying pull request, you start saying PR. So my PR, LGTM. So we're good to go. My boss approved it, and I can merge it, or I would actually let my boss merge it for me. Your assignment reviewer is going to look over it and let you know if it looks good. So, okay. So we're going to copy the address of this pull request, the URL, and submit it as your assignment. So when you go down and submit assignment, you are going to fill out this form, and then where it asks you to the link to your coding assignment, pull request final project repository, paste that. And almost every student uh, submits the wrong URL. So it's just something that happens. So uh, it's going to happen. You're going to submit the wrong URL, but if you don't, then props to you. I'm proud of you. It's really just to double check that you have the right URL, copy it, and then open up a new tab and paste it into your URL bar and press enter. If it brings you to the page that has my first commit and you're on the pull requests tab and stuff like that, that means you're on the right one. If you submit it on the code tab, your URL is going to be a little bit different, which the code tab, this is kind of like the base. If you open up a new repository, just this is like the basic or the like entry page. It's easy for your reviewer to go from this page, from this URL to pull requests. It's just one small change. You click there. So your assignment reviewer should be able to figure it out. But just to make their life a little bit easier, try to make sure you get the right URL there. And so go to pull requests or just after you make your pull request, just copy that URL and you can double check it. Make sure that it's the right one. It should have pull and then -1 or something like that at the end. Okay, and that's where you submit and then the rest of your stuff. So, okay, that's it. That's Git, GitHub, some very basics of the command line, very basics of using VS Code. Again, all these things, there's a lot to learn and it takes a while to get comfortable with it all. A lot of you are probably going to get stuck and need help from time to time, and that's totally fine. That's why we're here, mentors and CILs. So feel free to reach out. Um, okay, that's all. I'll, yeah.